Why don't planes crash all the time? Not how they fly. We've accepted that miracle. The real question is how a massive metal machine races through the sky millions of times a year without disaster. Because humans make mistakes, constantly. Yet aviation is one of the safest systems ever built. Crashes shock us precisely because they're rare. That's not luck. Things go wrong all the time. The difference is simple. Aviation assumes failure and builds systems to stop it from becoming fatal. Aircraft are engineered with mistrust. Modern airplanes are not designed with optimism. They are designed with suspicion. Engineers assume that components will fail, sensors will lie, and systems will malfunction at the worst possible moment. So instead of hoping for perfection, aircraft are built to survive imperfection. Critical systems are redundant by design. If one hydraulic system fails, another takes over. If a flight computer malfunctions, backups immediately step in. Even basic instruments are duplicated so that no single failure can deprive pilots of essential information. This layered design philosophy ensures that a problem rarely becomes a catastrophe. Before a new aircraft is certified, it is pushed far beyond normal operating limits. Wings are bent until they nearly snap. Engines are tested against bird strikes. Systems are deliberately shut down mid-test to prove the aircraft can still be controlled. By the time a passenger steps on board, that airplane has already survived conditions far worse than it will ever encounter in service. Pilots are trained for the worst day, not the best one. Pilots do not spend most of their training learning how to fly smoothly on a sunny afternoon. They train for chaos. Simulators repeatedly throw them into engine failures, electrical failures, unreliable airspeed readings, extreme weather, rejected takeoffs, and time-critical emergencies. But aviation learned long ago that technical skill alone isn't enough. Many historic accidents weren't caused by lack of ability, but by poor communication, hesitation, or authority breakdowns in the cockpit. That realization changed everything. Crew resource management transformed pilot training by forcing structured communication, cross-checking, and shared responsibility. Today, co-pilots are trained to challenge captains when something feels wrong. Silence is treated as dangerous. Clear communication is treated as life-saving. The result is a cockpit culture where mistakes are expected and corrected early. Maintenance is a system of controlled obsession. If pilots are the visible guardians of safety, maintenance crews are the silent enforcers. Aviation maintenance is governed by strict schedules, inspection intervals, and documentation requirements that leave little room for improvisation. Parts are replaced long before they are expected to fail. Inspections are scheduled not by guesswork, but by reliability data gathered across global fleets. Every repair, adjustment, and anomaly is recorded, creating a detailed history of each aircraft. This obsessive documentation allows airlines and regulators to detect patterns early. If a component begins failing more often than expected, it triggers investigations and mandatory fixes across entire fleets. Aviation doesn't wait for dramatic failures. It treats minor irregularities as warnings from the future. Air traffic control turns chaos into order. Even a perfectly maintained aircraft would be dangerous without structure in the sky. Thousands of planes share the same airspace every day, often separated by minutes or seconds in time. Air traffic control exists to keep that invisible choreography safe. Controllers manage aircraft using structured airspace, altitude separation, standardized routes, and strict procedures. Separation standards are intentionally conservative, leaving margins that account for human error and unexpected changes. Modern surveillance technology has dramatically improved this layer of safety. Controllers today see aircraft positions with far greater precision than in previous decades, reducing uncertainty and increasing reaction time. The sky looks calm because an enormous amount of invisible coordination is happening constantly. Planes now announce where they are. One of the quiet revolutions in aviation safety is something most passengers never hear about: a DSB. Instead of relying on ground radar to guess where an aircraft might be, modern planes continuously broadcast their exact GPS-based position altitude, speed, and direction, often updating every second. This data is received by air traffic controllers on the ground and by nearby aircraft in the sky, creating a shared, constantly refreshed picture of airspace. The impact of this shift is subtle but enormous. Older systems worked on approximation and prediction. ADS-B works on precision and certainty. Controllers no longer need to infer where planes are headed. They can see it instantly. Aircraft spacing becomes tighter but safer. Routing becomes more efficient, and blind spots, especially over oceans or remote regions, shrink dramatically. It perfectly reflects aviation's core philosophy: reduce uncertainty wherever possible, because uncertainty is where accidents are born. Aircraft watch each other. Even with advanced air traffic control and satellite surveillance, aviation assumes a simple truth: humans can miss things. Radios get congested. Controllers manage dozens of aircraft at once. Situations can change faster than voices can react. So aviation adds another layer: aircraft that actively watch each other. Modern planes carry onboard collision avoidance systems that independently monitor surrounding traffic. These systems don't wait for instructions from the ground. They calculate closing speeds, predict conflict paths, and issue clear cockpit alerts if separation becomes unsafe. In extreme cases, they don't just warn. They command immediate climb or descent maneuvers designed to resolve the conflict within seconds. This layer doesn't replace pilots or controllers, it supports them. It exists for the moments when everything else is already stretched thin, and in rare but critical situations, it has saved lives by reacting faster than human decision-making ever could. Safety systems learn from what almost went wrong. Perhaps the most powerful safety weapon in aviation isn't dramatic at all. It's learning from events that never make the news. Modern aviation treats near misses, unstable approaches, runway incursions, abnormal system warnings, and pilot reports as valuable intelligence rather than embarrassing mistakes. Every almost becomes data. Every anomaly feeds databases that look for patterns across fleets, airports, weather conditions, and procedures. Investigators and safety teams don't ask, "Who messed up?" They ask, "Why did this situation exist at all?" This mindset allows aviation to fix weaknesses before they turn fatal. It's why safety improves even in years without major accidents. The system doesn't wait for tragedy as permission to change. It treats quiet warnings as urgent messages from the future. Why crashes still happen? With all these layers, it's fair to ask, why do crashes happen at all? The answer is simple and uncomfortable. Aviation operates in the real world. Weather is unpredictable. Machines are complex. Humans make decisions under pressure. And sometimes, rare combinations of failures align in ways no system fully anticipates. Some years pass with almost no fatalities. Other years see sudden spikes caused by a small number of severe accidents. That doesn't mean safety collapsed overnight. It means statistics are sensitive to rare events. What matters is the long-term picture. When measured per flight, commercial aviation remains extraordinarily safe. Aviation safety isn't about eliminating risk entirely. That's impossible. It's about pushing risk so low that accidents become shocking exceptions instead of expected outcomes. And judged by that standard, the system is doing exactly what it was designed to do. The real secret behind aviation safety: the true reason planes don't crash often has nothing to do with confidence. It has everything to do with humility. Aviation assumes humans will be tired, distracted, rushed, or confused. So it builds checklists to catch memory failures, training to catch skill gaps, maintenance to catch wear, air traffic control to catch spacing errors, onboard systems to catch conflicts, reporting systems to catch patterns. It is not a single safeguard. It is a web of protections, layered so that when one fails, another steps in. And that's why flying feels boring most of the time. Boring is the sound of a system doing its job perfectly. If you enjoyed pulling back the curtain on the hidden systems that quietly keep you alive in the sky, like and subscribe for more deep dives into the invisible networks running our world. New videos coming. So like and subscribe, and I'll see you in the next one.